Hey everybody, today we are looking at section 11.4, which is going to be all about spheres. So we are going to end up looking at the surface area and the volume of spheres. So first thing is a sphere is a ball. Okay, so when they say it's a locus of points from one spot, you basically, like when we do a circle, we take that center point, we draw our radius all the way around in 2 dimensions, that creates our circle. Well, now we take our radius, we draw it all the way around in 3 dimensions, and that creates our sphere. A hemisphere is half of a sphere. So like when we think about the Earth, we have the northern hemisphere and the southern hemisphere. So that's, the top part and bottom part of our globe. Then we have the eastern hemisphere and the western hemisphere, and that splits the globe, left, right. The great circle is the largest circle that can go around the sphere. It divides it into the 2 hemispheres. The equator is a great circle. All right, so that's just kind of some of our vocabulary. Now, formulas. Volume of our sphere is 4/3 pi r cubed. This is on your reference sheet. Okay, so the volume formula for your sphere is on your reference sheet. The surface area formula, which is 4 pi r squared, is not on your reference sheet. So the nice thing about spheres is they're super easy because all you need is your radius. All right, so let's take a look at some examples. This should not be there. Sorry. Okay. So we want to start by finding the measurements and giving our answers in terms of pi. So for part A here, we're going to be looking at finding just the volume of the sphere. So my volume formula is that volume is 4/3 pi r cubed. Okay. My radius here is 9. So I'm going to do 4/3 times 9 cubed times pi. Okay, so 9 cubed is 9 times 9 times 9. Then when I multiply that by 4 and divide it by 3, I'm going to get 972 pi, and that's going to be centimeters cubed because, again, we are in volume. All right, so we want to make sure that when we're dealing with volume, again, that we're using those correct measurements. If you're struggling with putting this 9 cubed in your calculator, there is a cubed button. But if you can't find it, just do 9 times 9 times 9, and that'll get you in the same spot. All right. All right, next we're going to take a look at part B. And we want to find the diameter of a sphere when we know the volume is 972 pi inches cubed. So the first thing I do, I know the volume. So if I find the radius, then I can figure out what the diameter is. So my volume formula again is 4/3 pi r cubed. All right, so what I'm going to do here is plug in what I know. I know that my volume is 972 pi, and then that will equal 4/3 pi r cubed. So first thing I'm going to do, divide both sides by pi so that those can drop away and have 972 is equal to 4/3 r cubed. Now, to get rid of my 4/3 here, we're going to multiply both sides by 3/4. And when I do 972 times 3 divided by 4, I'm going to get 729 is going to equal r cubed. Now, when I have like 36 equals r squared, I square root both sides to find my radius, or to find my variable. Okay, so a square undoes a square root. I have a cube here, so I'm going to kind of write it over to the side a little bit. So to undo that, I need a cube root. So it's the same radical symbol, but we put a little 3 here. So remember when we were doing square roots, where when we did our factor tree, it was like 2 and 2 and 3 and 3 and 5, whatever. It doesn't matter. What we looked for pairs. Okay, so the 2 would come out here, the 3 would come out here, this would be 2 times 3, and my square root of 5 would be left over. Again, I don't care what the number is at top, but that's how it worked. When we're doing square roots, we're looking for pairs of 2's. Well, when I do cube roots, I'm going to be looking for triples. So when I look at 729, and you're not going to really have to factor tree all that often. I'm just showing you why it works. Okay, 729 is saying 3 times 243. Okay, 243 is 3 times 81. 81 is 3 times 27. 27 is 3 times 9. And 9 is 3 times 3. Okay, so when I'm looking for cube roots, in order to pull a cube root out, I'm looking for triples. So I have 2 pairs of 3's that come out. So it's 3 times 3. So that's going to be 9. So 9 times 9 times 9 is 729. So, didn't change colors back. So that means that my radius is 9. Okay. Now, there's a button in your calculator for how to cube root. What you're going to be doing, and I will go through this with you guys in class tomorrow on how to actually do the cube root, but you're going to type in your number that you're cube rooting. So in this case, you're going to type in 729. Okay, then when you're looking at your calculators, you're going to be looking for the X root button. Okay, actually, I lied. On your scientific ones that you have to use for the FSA, there is a cube root button. So instead of just hitting square root, you would hit second, and then it's above the 0. You'll see it'll say 3 and then the radical symbol. Okay, so that's the cube root. So you really are just worrying about hitting that there. But just know that that's where it comes from. This information over here is why in square roots we look for pairs. Cube roots, we're going to look for triples. If we look for fourth roots, it's going to be groups of 4, okay? So those are the kinds of things that are kind of going to be new and a little more challenging with this lesson, is working with that cube root. Now, I'm still not done because I want the diameter. So the diameter is 2 times my radius, so diameter is 18 inches. Inches is a length, diameter is a length, so there's no squared or cubed here. All right. Then we're going to take a look at the volume of the hemisphere. Okay, a hemisphere is half of a sphere. So my volume formula is 4/3 pi r cubed. Well, for a hemisphere, I want to take half of that, which means that if I look at 1 times 4 is 4, 2 times 3 is 6. So I have 4/6, which is 2/3, because half of 4/3 is 2/3. Okay, so this is going to be my formula for a hemisphere. It'll be 2/3 pi r cubed. So we're going to do 2/3 times 4 cubed times pi. So when I do 4 times 4 times 4, or 4 cubed, and then I multiply that by 2, I'm going to get 128. And then divide that by 3. This is not a nice number, so we're going to go ahead and just leave it as a fraction. Again, remember this is over 1. So you can do 4 cubed times 2, get this number, and just put that over 3. That way, if you do this and it's not a decimal, that's kind of where you need to go, all right? Or excuse me, if it is a decimal, you need to change it back to this fraction. And it is meters cubed because it is volume. Sorry, I got distracted in the middle of my thought there. Okay, so volume is cubed, so make sure you have, again, your correct unit. All right, let's take a look at surface area. Okay, my formula for surface area is 4 pi r squared. So if my diameter is 10, that means my radius is 5. All right, so again, my surface area formula is 4 pi r squared. So I'm just going to plug in what I know. My surface area is 4 times 5 squared times pi. 5 squared is 25 times 4 is 100. So this is going to be 100 pi feet squared, because again, it is area. All right. Now, next we want to know volume of a sphere when I know the surface area of the sphere. Okay, so here's kind of the thing with this one is I want to go to volume, and the only variable that I have in volume is my radius. So I need to figure out what my radius is so that I can find volume. Well, my surface area formula, so I have surface area is 4 pi r squared. I can use this to find the radius, then plug that in for volume. So I'm going to plug in what I know. I know my surface area is 144 pi. That's going to equal 4 pi r squared. So again, I'm going to start by dividing both sides by pi. So I get 144 is equal to 4r squared. All right. From here, divide both sides by 4. I'm going to get 36 is equal to r squared. And then we square root both sides to get that 6 is my radius. Now from here, I can use my volume formula, which is 4/3 pi r cubed. And I can plug in that my radius is now 6. So it's 4/3 times 6 cubed times pi. So when I calculate this information, I'm going to get 288 pi, and that's going to be, again, meters cubed for volume. Okay, let's take a look at part C. Okay, I have a surface area of a sphere that has the area of the great circle is 4 pi inches squared. So the area of this circle, okay, the radius of this circle is the same as the radius of the sphere. So if you think about it, area is pi r squared. Surface area is 4 pi r squared. So does it make sense that because these have the same radius, if we were talking about different circles with different radii, this would not work, but it has the same radius. So since pi r squared is equal to 4 pi, doesn't it make sense that I can take that 4 pi and plug it in here for pi r squared? Okay, this is pi r squared from over here. If it doesn't make sense, then you would do 4 pi is equal to pi r squared. Divide both sides by pi to get 4 equals r squared. Then you square root both sides to get that 2 as your radius. And you could plug 2 in over here and that would be fine. But if you recognize that surface area is the area of the great circle times 4, well, if they give you the area of the great circle, then all you have to do is multiply that by 4. So that way we have surface area is 16 pi inches squared. All right. Now, let's take a look at a composite figure. So when we're looking at the composite figure, we want the surface area and the volume. So I'm going to start with the surface area. All right, with the surface area, I need the surface area of a hemisphere. Okay, because I don't want the entire sphere. I just want the surface area of half of the sphere that is on the top. Okay, now if I look down at the cone for what's next, I only want the lateral area. We talked about this before because this base right here is inside the figure. I'm not going to count it in my surface area. So I'm going to do this and I'm going to add the lateral area of the cone. So my surface area. All right, surface area of a sphere is 4 pi r squared. Okay, so when we're doing surface area of a hemisphere, it's 2 pi r squared. Okay, because when we're looking at the hemisphere, it's half of 4 pi r squared. Okay, so that's where that 2 pi r squared comes from. Then the lateral of area of the cone is just pi rl. So when we plug in here for what we know, I know that's 2, my radius is 7 squared times pi. Then again, my radius is 7, and my slant height here is 25. And we multiply that times pi. So this is going to be 49 times 2, which is going to give me 98 pi here. And then 7 times 25 is going to give me 175 pi here. So my total surface area is going to be 273 pi centimeters squared. Okay? Now, for volume, I want the volume of the hemisphere plus the volume of the cone. Now, so my formula for volume of a hemisphere, remember the whole sphere is 4/3 pi r cubed. So the hemisphere is 2/3 pi r cubed. And the volume of the cone is that 1/3 area of the base times height. So that area of the base is pi r squared times the height. Now, when we go to start kind of plugging things in here, okay, my radius is still 7, okay, for both the cone and the hemisphere. So I have 1/3 here, 7 squared, and then, okay, I don't have my height. So we need to come over here, realize that this is my height, and I need to do Pythagorean theorem. I'm going to do 7 squared plus h squared is equal to 25 squared. And again, this is where knowing some of your triples can make life a little bit easier. But this is going to be 49 plus h squared is equal to 625. When I subtract from both sides, I'm going to get 576. And when I square root that, I'm going to get that 24 is my height. All right, so 24 is going to go right here. So then we're going to go ahead and calculate through with this. This is going to give me 686 over 3 pi, because an easy way that you can kind of check and see whether or not you're going to be divisible by 3 is this number divisible by 3, that initial number. Okay, because if this isn't divisible by 3, chances are you're going to be over 3. All right. And with this one, it's going to be 392 pi. So what I want to do is kind of convert this to thirds, so that way I can add these together. So this is that 686 over 3 pi. Now, what I'm going to do is I'm going to take that 392 and I'm going to multiply it by 3. So this is 1176 over 3 pi. So when you divide this out, you get back to that 392. So when I add these together, I'm going to get 62 over 3 pi centimeters cubed. Again, we're being told to leave this in terms of pi. So we want something that is not a repeating decimal here. All right. Okay, let's look at one application problem here. And we're talking about BTUs. A BTU is a British thermal unit, and it's a unit of energy. Okay, it's basically the amount of energy that you need to increase the temperature of water by 1 degree. And they use a pound of water by 1 degree Fahrenheit, and that's going to be a BTU. And we can look at BTUs in terms of volume, like how many BTUs is in here. So if we look at this problem 4, we have a spherical gas tank, and it provides 275,000 BTUs. Okay, so what we want to know is if I can figure out how many BTUs in 1 cubic foot. Okay, so what I want to do is first thing I want to find the volume of my sphere. So that way I know that I have 275,000 BTUs for however much volume. Then I can divide those out and figure out how many BTUs are in 1 cubic foot. So we're going to start by finding volume. So volume is 4/3 pi r cubed. Okay, realize that since this is 8, each piece of the diameter here is 4. So my radius is 4, so it's 4/3. And then it's going to be 4 cubed times pi. Okay, and again, 4 is not going to be divisible by 3, and neither is 4 cubed. So we're going to basically do 4 cubed times 4, which is essentially 4 to the 4th, which is 256 over 3. Those do not divide nicely. Okay, so that's going to be my volume for right now, and that's going to be cubic feet. So now what I'm looking at is I want to take, okay, I know I have the number of BTUs that I have, and I want to take that and I want to divide it out by the volume. All right, so that's going to be that 275,321 divided by that 256 over 3 pi. Now, again, we leave it like this just so it's fully accurate and you're not worrying about, well, did I round it right or did things get off? It will be correct when you get here. Again, the whole point of these is to maintain accuracy until the final round. Okay? So when I put this divided by this in my calculator, now again, just like we did before, you need to put parentheses around this when you're doing this in your calculator. Actually type in the parentheses so that way you're not dividing by 256, then multiplying by 3, and then dividing by pi, like doing weird things, okay? So make sure you put all this in your calculator in one shot, and then you're going to divide that out by that 275. So when I put this in the calculator, you should get 1027 to the nearest whole number. So we're going to the nearest BTU, and that's BTUs. So again, it's not as important for you to know like what a BTU is. It's just a measure of energy, and it's how much fuel or how much energy is needed. So like when I'm looking at this, I would say, okay, for every cubic foot, I can use 1027 BTUs. That's how many is in that gas tank. Okay. So if you do have questions on that, make sure you write those down so that way the next time you see me, you can ask. And then this is the last lesson for chapter 11. So yay. And I will see you guys later. Have a great day.